Hi there, question 15, a sort of an English interpretation question. I better read the questions first. So I'm going to be looking for a piece of apparatus, or the piece of apparatus that can create these high pressures. So I'll just write something at the side. And I'm going to be looking for how to calculate the pressure in atmospheres when you're told what the pressure is in gigapascals. So I think I'll write pressure in atmospheres at the side. Or maybe I'll just write atmospheres. And we're asked to suggest what would happen if would be observed if the pressurized sodium was placed in the circuit below. So I think I'll just write in circuit. And we're asked to write an equation using symbols and formula to show the decomposition of iron 3 oxide at high pressure. So I will write iron 3 oxide at the side, or maybe I'll just underline it there. And now I shall read it. The bizarre world of high pressure chemistry. What would happen if you put some sodium, normally a soft grey metal, under extremely high pressure? Researchers investigated this using a piece of apparatus called a diamond anvil cell. And that's the answer to question 1. The diamond anvil cell contains 2 diamonds, and as the screws are tightened, a high pressure is created. The pressure between the diamonds can reach 1000 gigapascals, which is a pressure of 10 million atmospheres. Oh, sorry, that's terrible. Right, so this is where it tells you what the relationship is between gigapascals and atmospheres. When sodium is squeezed to 190 gigapascals, it loses an important property of metals. It becomes an insulator. This shows that there's a change in the structure of the bonding sodium. The diamond anvil cell also allows scientists to create new materials, including superconductors. Scientists are studying what happens to materials thought to be deep inside the Earth, where high pressure occurs naturally. Using this technique to mirror what happens to materials deep in the Earth, iron 3 oxide is found to decompose, releasing oxygen and forming a very unusual iron 5O7. So this is that last question, where iron 3 oxide becomes oxygen and Fe5O7. And now, just to write it all in, name the piece of apparatus, diamond anvil cell. Be quicker if you were doing it, because you wouldn't have to keep scrolling up and down. Calculate the pressure in atmospheres when sodium is squeezed to 190 gigapascals. So we are told that 1000 gigapascals is 10 million atmospheres. and we actually want 190 gigapascals. So a good way to set about doing this is to find 1 gigapascal by dividing by 1000. So 10 million divided by 1000, let's just call it 10 over 1000 million. And now we can go from 1 gigapascal to 190 gigapascals by multiplying by 190. So 10 over 1000. So I'll put that in my calculator. 10 divided by 1000 times 190 is 1.9. Atmospheres, million atmospheres, don't forget the million. That's the answer. Suggest what would be observed if this pressurized sodium was placed in the circuit below. Well, when I was reading the passage, it said it was an insulator, so I'm going to say that the bulb will not light. Write an equation using symbols for the formula to show the decomposition of iron 3 oxide. Iron 3 means it's got a valency of 3, and I hope you know that oxygen has got a valency of 2. We'll go up here and have a look at it. So iron 3 oxide releases oxygen and iron 5O7, which I shall just write down. And 5O7 and oxygen. Now iron 3 oxide, what's the formula for that? So iron 3 has got a valency of 3 and oxygen has got a valency of 2, and you do that little crisscross thing, put 2 there and a 3 there. Thanks for watching. Bye.